Yep. Okay. All right. Quick intro. Yash comes to us from Lookout, which is a mobile security company, and basically, I think there's a lot to learn from them and them from us. And so Yash is going to talk about Hadoop and their ingestion and analytics that runs on.
Thank you very much, Andre. I'm going to project a little louder than usual because the camera doesn't have the best of mics, so if I get too loud, please bear with me. So thank you very much, Andre, for inviting me here. Like Andre said, I actually was at one of Andre's talks at Sift Science a couple of months back, and I talked to him and I said, hey, we should, I think we can learn a lot from each other. So Andre gave a great talk at Lookout last month, and then I'm doing it now, and hopefully we'll do more in the future. So feel free to have more talks. So today I'm going to talk about our data ingestion pipelines, if the computer allows me to. So that's me, Yash, and what we're going to talk about is what we do at Lookout as a company, our analytics infrastructure and architecture, and what kind of the teams it serves, our some of our event ingestion pipelines into Hadoop, and finally, I'm going to talk a little bit about Storm. I know you guys are in AWS and you guys use SQS, but if there's a lot of stuff that I've played with Storm, and if it gets too boring, stop me. I can definitely talk about something else, but that's definitely something that's it's been a fun for me to work with Storm. Probably we'll open it out for questions. And please feel free to stop me if you have any questions in the middle. So that's a little bit about me. I'm a data engineer at Lookout. I've been there for the last year and a half, a little over a year and a half. And I've been previously at Demandbase Project Performance Corporation. I was Demandbase is here in the Bay Area, and PPC was a consulting firm back in the East Coast. So I moved here in 2011. So I've been here about 3.5 years-ish. I'm originally from Mumbai, India, and that's my blog. If you ever want to take a look at it, I put snippets of data engineering awesomeness over there. So what do we do at Lookout? Who here has heard about Lookout before? Okay, so that's pretty much everyone. That's awesome. That's great. So I'm glad everybody has. So we Lookout are a mobile security company, and oops. Did not expect to do that. That's fine. I'll use too many widgets. So our mission is to make smartphones and tablets more secure for people and for organizations. And the way we do it is through a mobile app. Whoa, too many distractions. I should just close this. Sorry about that. So the way we do it is through a mobile security app, and as you can see that it's the Lookout mobile security app, and we have the antivirus, a missing device feature, which allows you to locate your phone, and backup feature. So we have over 60 million registered users, and growing. So in analytics infrastructure, before I start talking about it, I just want to say what the kind of people that we serve in the data team. Our product managers are asking questions on how well a particular feature is doing within the product, or software developers who want to look at how their code is coming down, and the JSON that they were sending, or the blobs, or the protobufs, or whatever they were sending to the clients, how they come to our servers and look at that, and people in marketing to answer questions about how well we are doing in certain regions and certain parts of the world. And then finally, security research, which is our bread and butter, the people who actually do the research on these applications or the malicious applications. They use our infrastructure to figure out and do a whole bunch of analysis on the platform on our large data set. So as you can see, it's a very mix of people, it's not only for one person. So, and each and every team has its own set of requirements. The data analytics team is composed of 7 analysts and data scientists /data scientists, and like I said, the questions they answer are, how many users located their phone yesterday, how many users were billed with AT&T, and so on and so forth. And then we have 3 data engineers on the team, including myself, and we will then maintain pipelines for analytics and the software engineers and anybody who really wants to take a look at our data in the warehouse. Here's a kind of brief diagram about our architecture. As you can see, we have internal and external data sources, and so there are like 1,000 lines coming from that into the warehouse. And we get data from pretty much anything you can imagine: Box, external files that are on FTP somewhere on a client server, or pretty much anything you can imagine. And our data warehouse consists of a MySQL warehouse and a HDFS or Hadoop warehouse. And the MySQL warehouse is a standard star schema warehouse, which has tables with dimensions and facts and so on and so forth. And we take that and we replicate that over to Hive pretty much every night. And in the HDFS side of things, we use Hive, which maybe people use it here as well, or some. Okay, you don't use it, but it's basically it's not really a database. It's a MapReduce writing framework. So you give it SQL and it writes MapReduce for you, and it runs the MapReduce code on your data, which exists on the Hadoop cluster. So people call it database, but it's not really a database. HBase is actually a database, and whereas Impala is also another sort of framework which allows you to run queries on that. It's much faster than Hive. So depending on what our data latency requirements are, we have different sorts of things we query off of. And then the warehouse is then queried by this layer of a whole bunch of, I would say, ad hoc tools and real-time tools, and then just like canned reporting tools, which then get sent out to people within the organization. So in reporting, our bread and butter is Tableau in terms of dashboards. So for example, we'd have dashboards for retentions, activations, how many people are coming on our platform, so on and so forth. And Tableau also has an email reporting tool built along with it. So those are the main things that we use for dashboards. And we also have a custom inbuilt, homegrown reporting solutions that we just send out. We send emails through that. For ad hoc querying, we have a whole bunch of tools that we use. One is the Hive CLI. It's just a command line interface into Hive. Allows you to write SQL statements and get the results. And Hue is a, sorry, go ahead.
What's the latency on a Hive query? I guess like a moderately complicated one.
Yeah, so what happens is when you write the SQL, it gets converted into a MapReduce program, Java program. The jar gets shipped to nodes, and the nodes basically run them, and they come back. So it's a lot. The short answer, it's a lot. As compared to something like HBase or Impala, where your answers are pretty fast, but their use cases are a little different. But I think Impala is the fastest you're going to get in the Hive family of things. But it could be in few minutes to maybe like an hour, depending on how much data you are looking at and how many resources you have available. To answer,
Yeah.
So Hue is a pretty cool, it's a Toad style a tool which allows you to write queries on top of Hive or Impala for that matter as well. And so the lot.
Sorry, what does that mean, Toad style?
Toad style. So probably people haven't heard of Toad. Okay, Toad is a tool which was pretty popular maybe 4 or 5 years ago, and they used it to query pretty much. The good thing about the tool was you could allow it would allow you to query any database. It would be MySQL or Oracle or whatever. So, but it's not a lot of people use it anymore these days. But it's a GUI basically, and you type in your queries in there, and then you can hit run, and you get your result sets. You can query through those, go through those result sets, and scan them, and do all sorts of like download them as CSV and so on. So that's Hue. A lot of the analysts use it for doing ad hoc querying on the database. Our studio we use a lot. The data scientists use a lot to do just ad hoc reporting or analysis on the data. For example, thread data, and kind of figuring and doing a lot of visualizations on top of the data. And Shiny is a cool tool which builds on top of our it's actually a R package, or if I got that right, it's a R package. I'm not quite sure how it works, but it's a web server, and it gives you a dashboarding interface into your data via R. So it's really good for data scientists, because a lot of data scientists don't really want to, at least in our company, don't really want to write MapReduce code. So they would rather write SQL or something, or R, something that they're more familiar with. And Sparkle Pony, that's a homegrown Ruby app. We have fun app names. We have Pony Fuel, Sparkle Pony, that's one of them. But that's just regular MySQL querying for some of our project managers. If they want to take a look at our data and just run a quick ad hoc query, they can log into the system and run the query off the MySQL data warehouse. And then again, we just look into the Hadoop file system every once in a while if we ever need it for just basic stuff like Taylor file or something. So we have a whole bunch of options available for us. So I'll talk a little bit about event ingestion pipelines. Data comes in through several sources. We have text data, coming in through JSON. We have binary data coming through protobufs, and we have a lot of database replication that goes on. So we also have bin logs, which we actually, from MySQL database, we have bin logs which we parse and extract data out of that. So I'm going to talk a little bit about protobufs later, but who here has heard about protobufs or ever? Okay, a lot of them. I know one person didn't put their hand. So, but basically, binary. What protobufs is, it's a binary protocol for defining schemas, and it just helps in schema evolution and people with multiple different schemas talking to each other. It helps in that. So we definitely use protobufs, and so far it's been good. We haven't done a whole lot of things with it, but as we go forward, we're actually ingesting only protobuf data and storing it in Hive, and then now we're at a position where we want to query that data on top of Hive, and that's been a challenge for us. There are a couple of tools out there that do that, not that great, but we're looking into how to make that process better. Next slide. So this is just like a sample of the pipelines that we have. We have a bin log parser which we open sourced. It's called Mudskipper, and what it does, it allows you to track a MySQL table and then track updates or new additions to it, and then write that data into Hadoop. So this is great if you have already, like us, if you already have a MySQL database that you are tracking, which we do because our front-end tool is, our front-end servers actually write a lot of data in MySQL. So we track that. And then we use ActiveMQ, which is a message queuing framework. It is cluster, you can run it in a cluster, but it's not that great as compared to Kafka. Kafka is way better of doing that. And more and more data that we are seeing now is coming through Kafka. And what we are doing is we are actually taking that data and writing it into HDFS via Storm. And a lot of times we have two types of pipelines that we run that read data from Kafka. One sort of pipeline is the actual just a raw dump of what is being published on the queue, which we take and then compress and then write to HDFS. This is if we ever wanted to, like a year from now, if we ever wanted to look in our logs, we can look at that. And the second type of pipeline from Kafka is the actual processing of the data, which is what we do with Storm. We would convert stuff in, like UTC. We would convert the timestamps, or we would do some sort of logic on top of the stream data and then write it into Hive. So those are the two main pipelines. And then again, we have some Ruby daemons which read data from ActiveMQ and then write it to Hive, but we're not really happy with the way they are, because to have the daemons, you have upstart scripts, you have to have monitoring, and it's much easier to have a single platform that does your monitoring and the processing and so on and so forth, which is what we get through Storm. Any questions before I move to the next slide? Sure, go ahead.
Yeah, I guess you guys maintain all of your own infrastructure? Or
Yes, we do. Yeah.
Okay, nice.
Yeah. We are planning to move slowly. We're planning to move into AWS That's going to happen in the future. But yeah, for now we're just maintaining our own infrastructure.
Why are you planning on moving to AWS?
A whole bunch of reasons. So there are some people who think that there are cost benefits to it, and some people argue against that, especially with the Hadoop cluster. I'm sorry?
It'd be very surprising to me to be cost benefits.
Yeah. Well, if you think about it, having a data center, depending on where your data center is, it could be expensive or cheap or whatever. But you're right. I mean, especially for a Hadoop cluster, some people have said that it's actually 2 times as more expensive to run a Hadoop cluster in AWS versus if you were to have it in a colo. But again, I don't have any numbers or whatever. So, has your experience been the same?
I think. Well, we run AWS and it's very expensive.
Yeah. Yeah. So we're definitely gonna take baby steps and see if this actually makes the bottom line makes sense versus not spending as much money. But what we are doing right now with our colo platform, with the Hue and giving these tools to our analysts, we did an analysis, and I think if we wanted to do the same with AWS, it was really, really expensive. So we were waiting until there was like the stopgap, or not the stopgap. We were waiting for something which would not be that expensive. So, sorry. Should have changed my settings before I came in. Okay, so moving on. So I'm going to talk a little bit about Storm, and this is just, I think some of these principles would be applicable for any sort of stream processing framework. So I think that would be in all the, I don't know if you're using Storm. Are you using Storm? Okay. So I think it would be good for any sort of framework, but so hopefully this adds some value. So Storm is a distributed real-time computation system, and the great thing about this is, like I said, it offers you one platform. You write your application, you deploy to it, and then it sort of handles a lot of things for you. The good thing about that, you can also write in any programming language. We currently use Java, but there's no reason you have to stick to that. You can write in any programming language. So the way topology, before I go into topology, one of the 2 important abstractions in Storm are the Nimbus and the supervisor. The Nimbus is a node which is the master, it sort of controls everything, and supervisors are sets of nodes which run the actual topology. So if you were to think of a Java jar, for example, the Java jar would actually run on supervisors, whereas the Nimbus would just the Nimbus is the node where the jar is just submitted, and then it actually gives it to the supervisors. So there's no single point of failure in the sense that if your Nimbus were to die, if your main central node were to die, your supervisors will still continue to function. And then once the Nimbus comes back up, it would. Sorry, this is annoying. I know. I should probably turn this off. Okay, so that's the basic idea. It's working good for us, except for a few small things when it tries to write to HDFS. So the abstraction in Storm, which actually runs the core, does the core work, is called a topology, and a topology basically consists of spouts and bolts, and just as the word suggests, a spout is a data source. So it could be Kafka, it could be ActiveMQ, it could be pretty much any other thing which generates data, even a file, I think. So that's the spout, and the bolt then just processes the data. So if you were to make a database lookup, or if you wanted to just take the data and transform the way, or if you have timestamps that are in UTC, you want to convert it to PST, stuff like that. You can do that in the bolts. The other good thing about bolts is you can do a lot of aggregation stuff. There's there's a whole bunch of cool things we can do with the bolts. The way we use it, this is just a sample topology of what we do. We have our services, the front end services, which talk to the cell phones, the clients, write their data to Kafka, and then we have a Storm topology that just pick the data up. The topology is also distributed, so the Kafka topic is partitioned, and it's spread across a whole bunch of servers. And the Storm topology is also distributed, so it's spread across a whole bunch of servers. And they basically read the data from Kafka and then shove it into HDFS. And so we have a Kafka spout, something that does some processing, and then we have a Storm HDFS bolt, which just then writes to HDFS. So landing data into Hadoop, the way we do it is using an open source tool called the HDFS bolt. It's just open source bolt. I think it's written by a guy called Taylor Getz. He works for Hortonworks. Basically, the good thing about that is for us, what we want to do is we want to take the data and then put that in directories in HDFS. And what happens is those directories get rotated every so often. So if we have a data pipeline, and the reporting requirement for that is we want data as fresh as the last 10 minutes, we can have it rotate at that frequency. So we pretty much control how soon the data lands into HDFS. Like I said, so they're basically moved into a location in Hive. And once they're moved in Hive, then they're available for analysts or any sort of automated reporting platform that queries them. It's just Storm parallelism. I don't want to confuse you with this, but it's just how the Storm spouts and bolts are broken down. Okay, so topology deployment is something that we are not that great at, but we do it just the easy way. And the way we would deploy a topology onto a cluster is you build up your jar, you put all your classes in it, and then you create an Uber jar, and then you ship that jar up to the Nimbus, and the Nimbus then takes that and distributes it across supervisor, and then the supervisor just kicks off the jar with whatever options you provide in the command line. So, and then you can provide more arguments. For example, I want you to go to this database server in staging and with this database server in production. So you can specify that up in the jar. The way we do it is we actually have all our configuration parameters in a shell script. There are a lot of better ways of doing this configuration, especially if you have hundreds of topologies. They're constantly processing data and they're doing things. It's much easier to have this sort of abstracted out into something much cleaner. We're not there yet, but we'll probably be looking to do something like that in the near future. So one of the cool things we recently did with our Storm topologies is to get the metrics of the data streams. And for example, let me give you an example of what we did recently. A couple of months back, we were getting protobufs that were getting data that was encoded into protobufs by upstream producers, and then they landed that data into Kafka, and we were taking that data and we were actually deserializing it, understanding the data, doing some sort of processing work to it, and then writing it into HDFS. One of the things with protobufs is that it usually should work, but it's binary data, and sometimes there's corruption upstream. So we knew that there were certain producers. There were a set of producers that were writing down to the same topic, and they were all expected to for the V1 they were expected to just abide by a certain a protocol buffer definition file. And one of them was not. In fact, it was wrapping the data over this other service was wrapping the data, which we didn't want. And with Storm, there's a way to look at the topology. It has a nice UI, and you can look at the logs. But it's much easier to know if this is happening on a constant basis. You should get a graph of your real-time data streams, how they're looking in real time, how many failures you're looking at, how many successes, so on and so forth. So we use the Storm's metrics API, which is pretty great, and it has some counter aggregation stuff. And then what we did was we counted the number of successes and the failures internally, and then you send that to StatsD for monitoring. StatsD is a basic data aggregation framework that allows you to say, I have one message per second, and let's say you wanted to know the messages for the entire hour. It allows you to aggregate those that. And then we visualize that using Graphite. So here's an example of a graph. You can't probably see it very clearly from here, but in this topology, what's happening is that we have a lot of, the error count is just going crazy. We have a lot of errors here. And then the successes are very few. It's because there are a few good producers who are writing to the Kafka queue, but there are some producers that are really bad. They shouldn't be doing what they're doing. So we publish this on a TV at work, and we just keep looking at it. And if it just looks too bad, then we know your data quality is really bad. So that's that. That's pretty much it. Well, I should really learn how to switch off things before I start the talk. But that's pretty much it from my side. If you're curious what these slides are made in, they're made in a JavaScript framework called reveal.js, and all the stuff that you saw was all marked down. So it's just basic text which gets compiled to HTML, and then we convert it to HTML, not compiled, and then that's what I do. So I don't know questions. Please go ahead.
On the ad hoc query and on your normal data analysis, have you looked at columnar data stores like Vertica or Teradata, or what scale of data are you dealing with?
Yeah, so we're dealing with a lot of data. So the question is, if we looked at Teradata or Vertica or some of the columnar storage, I think we had looked at it briefly in the past before I joined the company, and we don't have a whole bunch of use cases where that would be useful. I think we have Hive that's okay for us. Although it's slow, it'll be slower than some of those databases, I think it's okay for us for whatever Hive does. So yeah, but I know they definitely have that. I don't know much about it, but there's definitely a value add to having those databases. Yeah. Any other questions? Yeah.
So you mentioned in your pipeline mostly push mechanisms from third-party data sources into your pipeline. Is there any pool, like a analyst or software engineer requires certain data that you don't have in your current data set? Could you go out and get it proactively, or is it just push?
So most of it is push. We do have some pull. For example, there are certain teams that within the organization, for example, we have a test team that are constantly monitoring how our apps are doing on different kinds of phones. And they would rather just send us a CSV dump on Box. And so what we do is we then monitor a Box folder, we're just constantly looking at it, and then we pull the data via Box. So that's one. The other way that we haven't done yet, but we're planning to do with Kafka is actually have batch jobs that pull the data via Kafka. Trying to think if there's any other pulls. We do have certain data pipelines which read data off of the Google API for Android, and that gives us metrics on how well our app is doing across different regions. So that's also a pull. I don't know if that answered your question.
I mean, for example, you have concept of sort of giving multiple answers to a query, like a fast answer and a slow answer. The fast answer has data that's currently present in the database, and the slow answer has.
Yeah, so we don't have, we do have certain things where we actually have a fast table and a slow table. It's not really a fast table per se, it's like more of an archival table and more of a real-time table. So we have kind of a sort of a Lambda architecture when we have a a Hive table and a HBase table. And they're both sort of, if you think of it, there's one view which sort of queries both the tables at the same time. So depending on what your timestamp is that you're giving, I want the rows between X and Y, it will go to either table, or actually it will go to both tables. So we have one pipeline that does that, where we have like a fast-moving data that we're just writing down to HBase for querying, and then another table in Hive, which is just exact replica of that, but it stores the old data. I see a hand somewhere. Yeah, sure. Yeah.
So this pipeline, is this mostly involved in data analytics for engineers, etc., or is there a production loop that is the output of the data is directly displayed or used or is contributing to production?
We don't have a direct loop to production. We have sort of indirect loops where we have analysis done on the data and then they sort of land into production some way, but we don't have any direct loop. So to answer your question, no. We don't have anything directly serving our clients, for example. We're planning to change that. We're planning to build an API on top of our data set. So a lot of, because we are at a position now where we do a lot of cohorting on our clients. So we take our clients down, and depending on, by clients I mean the mobile phones that we use, and depending on what Android version they are, and depending on what how much processing power they have, I'm not sure about processing power, but there's a whole bunch of parameters that we actually break down our clients into, and then we put them in cohorts. And now we have a requirement for taking that and then cross-checking that across the data warehouse, because that's where all the data from across the company lives. So we're going to build something that will be productionized, but we don't have anything like right off the spur of the moment a client needs an answer from us. We don't have that. Yeah. Sure.
I'm curious, at the scale of your company, do you guys have some sort of like resource management framework that is in place?
What do you mean by resource management?
So say that like there are a lot of people that are submitting job to the Storm Cloud.
Oh, okay.
And then,
Yeah, so we have a queue where most people submit their jobs to, where the analysts submit their job to, and I think it's called the queue in Hadoop, if I'm not mistaken. But yeah, we have one set of allocation resource, one set of nodes which are allocated for that, or the queue is allocated for that. I'm not quite sure. I didn't do that, but mostly we don't have a whole bunch of contention issues where we have multiple people trying to access the same thing. It's mainly, even if there are resources that are being accessed by other teams, which there are, they sort of stick to their own table space, so their own namespace of tables. So we never have a thing where we're somebody just killing up the cluster by spawning crazy amount of jobs. We do have that every once in a while, but a lot of times the problem is the number of files more than anything, right? So if you have a MapReduce job which spawns 20,000 mappers, there are certain things you should probably look at. If you have too many files, if it's really required to have 20,000 mappers, and so on and so forth. So we've mitigated some of that, but yeah, we don't really actively allocate resources other than the default.
So, do you have a concept of archiving all data, dropping it from, having a sliding window of data to analyze, to save on space and computational requirements, or do you keep all the data?
So right now we take snapshots of data, and we don't. For example, we would take a MySQL database table, which is a couple of 100 gigabytes, and take its snapshot over time, how it looked last month, the month before that, and we'll do that for the last 15 days. So we have some sort of archival in terms of that, archival policy in terms of that, but we don't have a policy throughout the cluster. So we pretty much retain all our data until the point where we figure out, okay, there's not a whole bunch of value in keeping this data, and then we would delete it if we wanted to. But I think moving forward, we're probably going to retain a lot of our data. We are looking into better efficient compression strategies, so we're not, that data is just not laying there uncompressed. But yeah, we're not refreshing or doing that.
It's not entirely on point with infrastructure, but have there been any like large mobile virus epidemics that you're allowed to discuss? Like, I never hear much about mobile security.
Yeah. So recently, yeah, that's actually a good question. Recently on our Lookouts Twitter page, if you look, our CTO talked about a virus called let me look. It's called not compatible, and I think this is a family of viruses, or actually a virus that is a result of a group, or maybe multiple groups. That's what the CTO says. That are responsible for installing malicious software on your, somehow they get to one device, and through that, the once that device connects to the VPN, then it infects other devices within the network, and then it actually relays those traffics to what's called a command control server, which basically controls, and it's basically a really sophisticated server which allows you to do crazy things in other people's networks. So this particular software is really interesting because it actually bypassed all sort of known command control servers, and it had, I mean, you should look at the video. He probably does a better job of explaining it than I'm, but it's a pretty sophisticated level of software. And mobile is, the usage of mobile in organizations is just increasing. So more and more people are going out, accessing the wiki, for example, or accessing different parts of the organizations just with their mobile phone. So there's more touch points and more attack vectors attack surfaces that are opened up because of that. So yeah, we like to think that it's going to get worse as mobile opens up, more operating systems come into being. So yeah, that's why we're in the business, and yeah. Cool. Any other questions? Cool. Well, you guys have my Twitter handle, so feel free to tweet at me or just email me. I'm always ready to answer questions or learn something. So if you ever want to give a talk, or if you have something cool to say, just not even tech or engineering wise, we always do have a lot of talks at Lookout. So if you have something fun to say, just come on over to our office. Love to show it to you.
Thanks.